Let's learn about ANOVA, which is used for testing continuous variables via different categories. So let's say our categories here is teaching style, whether they're looking at PowerPoints, chalkboard, or Zoom. And then we have different test scores of the students. So let's plot out our data. So let me start with the folks that are using chalkboard. Notice their test scores tend to be very high and around the same values. So the test scores might look a bit something like this, and these are the chalkboard folks. And then let's look at PowerPoint. PowerPoint, a bit more spread out, it tends to be on the higher end in like the 80s and the 90s. So maybe their score looks something like this. And then finally, let's see, let's add some color. Whoops. Okay, chalkboard is blue, PowerPoint is red. And then lastly, let's have Zoom folks. Their scores are all over the place, all the way from 60s all the way up to 90. So maybe something like that. So there's two things we want to look at for looking at ANOVA. One is the within variation, which is within a given category, how much variation is there? So this is within variation. So within the green, this is how much variation there is. And then we're also interested in between variation. So between the different categories, how much variation is there? So for ANOVA, what we want to calculate is known as the F statistics, which is going to be the sum square between divided by some degrees of freedom. We don't have to worry too much about that. Divided by sum of squares within. And then when I say sum of squares, just think of it as the variation and some degree of freedom, which we won't discuss. So we're comparing the sum squares between versus the sum squares within. So we say there's a significant difference. There's significant difference between teaching styles. If one, there's a large difference between the test scores. There's a large difference between test scores by style. So let's just say by style. So between styles, this would be the sum of squares between. And or there's tiny variance within a style. For example, the chalkboard folks, they tend to score very highly, and they tend to have very little variation, so it's quite tight, it's quite unique to this chalkboard teaching style, and that corresponds to the sum of squares within. So add some color really quick. So when we're talking about sum of squares between, if there's a large difference, that would be, is this difference very large? And if there's a large difference between either the green or the red, or the green and the blue, that's evidence for there being significant difference between the teaching styles. And or there's tiny variance within a style. So within the style, we could say like the chalkboard folks, for example, there isn't that much difference. Within chalkboard folks, they tend to be very concentrated around here. And as you see, you have a lot of between variance that'll make the F statistics higher. Same thing when you have the small within variance, that'll make the statistic higher as well. And then higher F statistics is more evidence for stat significance.